Step 8. In Step 8, we're going to learn how to add, subtract, and multiply polynomials. When we add two expressions together, we're really just combining like terms. Adding an expression does not change signs to any term. So I'm going to bring everything down. 5p squared minus 3 plus 2p squared minus 3p cubed. The 2p squared was already positive. The 3p cubed was already negative. Adding does not change the sign of any term. Now we're going to find like terms and combine them. I have a 5p squared and I have a 2p squared. Combined, I have 7p squared. I do not have another negative number to combine the negative 3 with, and I don't have another p cubed to combine the negative 3 p cubed with. Now, this is the simplified form. The only step we can take further is to put it in order from highest power to lowest power. Not necessary, but nice. P cubed is the highest power. We had to take the negative 3 with it. P squared is the second highest power, was a positive 7. And then our constant is negative 3. So here we have our final answer with the two polynomials added together. When we subtract has two steps. We need to distribute the negative, then combine like terms. When I distribute the negative, the first expression does not change. So I'm going to bring that down. Now, when I distribute the negative, it's like multiplying a negative 1 times 3, which would be negative 3a squared, and negative 1 times negative 4 will give us positive 4a cubed. When we distribute a negative, it changes the sign of each term. The 3 was originally positive, became negative. 4 was originally negative, became positive. Now we need to combine like terms. I've got an a cubed and 4a cubed. Don't forget about the invisible 1 in front of this a cubed. So I have 1a cubed plus 4a cubed. 1 plus 4 is 5a cubed. Now I have a negative 2a squared and a negative 3a squared. Negative 2 minus 3 is negative 5a squared. Here we already have the highest power first, so we're completely simplified. Let's go back to adding. When we add, the only step is to combine like terms. So I'm going to bring everything down, drop the parentheses. 4 plus 2n cubed plus 5n cubed plus 2. Look for like terms. I've got a 2n cubed and a 5n cubed. 2 plus 5, 7 n cubed. And then I have a 4 and a 2, both positive. 4 plus 2 is 6. Back to subtracting polynomials. So the two steps are distribute, then combine. So we're going to bring the first polynomial down, 4n minus 3n to the third. Now when I distribute the negative, it's like multiplying by a -1, which will change each term's sign. They were both originally positive. Distributing the negative will make them both negative. Now we will look for like terms. I have a -3n cubed and another -3n cubed. So I have -6n cubed. Then I have a 4n minus 4n. 4 minus 4 would leave us with 0n. And when we multiply anything by 0, it is 0. So there's no need to write 0. Here's a little bit harder addition. Just a little bit longer, not harder. So when we add, we bring everything down. We can drop the parentheses. We don't have to change any signs. The 3k to the fourth is negative, so it needs to stay negative. The 14k squared is negative, so it needs to stay negative, and the 8 is negative, so it needs to stay negative. Looking for like terms, I have a -4k to the fourth, a -3k to the fourth, so I have -7k to the fourth. I have a 3k squared and a -14k squared. 3 minus 14 is -11k squared. And then combining my constants, I have 14 minus 8. Which is +6. I've combined all like terms, and my terms are listed from highest power to lowest power. So my final answer is in standard form. Subtract. Distribute first, and make sure you distribute through the whole parenthesis. This one has 3 terms, so we've got to distribute the negative to every term in the parenthesis. First term comes down. Now when I distribute the negative to a negative, the -1 to -6 will make it +6n to the fourth. The negative to the -3n will make it +3n, and the negative to the -8n to the fifth will make it positive. They all 3 started out as negative. Distributing the negative makes them all positive. Looking for like terms, -6n to the fifth plus 8n to the fifth. -6 plus 8 is 2n to the fifth. -8n to the fourth plus 6n to the fourth. -8 plus 6 leave us with -2n to the fourth. Then I have a 3n, which I have nothing to combine with, so it will come down as +3n. And I have a constant of 3, and that 3 is positive, so it will come down as a +3. I have all like terms combined, and my final answer in standard form from highest power to lowest power. Alright, on to multiply. When we multiply one term by multiple terms, we distribute. This is review. When I multiply 2x times -2x, I multiply the numbers and add the exponents on like variables. Both of these x's have an invisible exponent of 1. So when I distribute or multiply this negative 2x to the negative 2x, I get 2 times negative 2, which is negative 4, x to the 1 plus 1, which is 2. Now when I distribute the negative 2x to the negative 3, you just have to multiply 2 times negative 3, which is negative 6, and I still have 1x attached to the 2, and I have 0 attached to the 3. So 1 plus 0 leaves us with the 1x that was originally attached to the 2. Let's review one more distributing. Distribute to everything in the parentheses. Negative 4 times v is negative 4v, and negative 4 times 1 is negative 4. So distributing, notice we have one term on the outside of the parentheses and multiple inside the parentheses. When we have multiple terms in both parentheses, the multiplication gets a little bit trickier. We're multiplying here. Using this method helps us stay organized and guides us through the problem with very little error. So we're going to take the first set of terms, everything in the first set of parentheses, and we're going to write them along the terms along the top. So I have 2n and 2 both positive, and I have 6n and 1 both positive. Now when I multiply, for this first box, I'm going to take 2n times 6n. 2 times 6 is 12. N to the 1 plus 1, which is 2. Here I'm going to multiply 2 times 6n, which is 12n. Here I'm going to multiply 2n times 1, which is 2n, and 2 times 1, which is 2. Once I have all my multiplication done, I'm going to pull out all the terms with their sign and now combine like terms. I have no other n squareds, so I'm going to bring that one down. I have 12n plus 2n, which is 14n, and I have a plus 2 constant to bring down. Let's try another one. So I'm gonna start with my box. I have a 2 by 2, so I need 2 terms along the top, 2 terms along the side. So the first one needs to stay together. Whether you put it along the top or along the side is up to you, but the 4n and the 1 need to stay together. And the 2n plus 6 need to stay together. So 2n and 6. Now when I multiply here, I get 8n squared. 2n times 1 is 2n. Here I get 24n and 6. I'm going to pull everything out. The only terms I need to combine are the n's. 2n plus 24n is 26n. Notice on this one that we had a -4 term, so that had to go down to the box as well. That way when we multiplied by 4, we were multiplying by -4. Alright, 2 more. So here I have 2 terms by 3 terms. So now my box needs to be a 2 by 3. So I'm going to make it a little bit longer. I need 2 terms along the top and 3 terms along the side. Alright, go ahead and multiply. Notice there's an invisible one on your A terms, A variables. So we have 24a to the 3rd, 12a squared, -4a squared, -2a, 8a, and 4. Pull them all out and combine like terms. Squared and a squared, a and a. (12 minus 4 is 8. (-2 plus 8 is 6. And we're simplified. Alright, again we need a 2 by 3. 2 terms along the top. Take the negative with the 3. 3 terms along the side. Take a negative with the 2k. And start multiplying.